Let's just go ahead and start off with your background. Maybe tell us a little bit about yourself.
Yeah, for sure. I'm currently a PhD student at Stanford University in my second year. I'm advised by Professors D.E. Yang and Ludwig Schmidt, and I have been working on coding agents, evaluations for language models, mainly focused in the software engineering domain. Before Stanford, I did my master's at Princeton University, advised by Professor Karthik Narasimhan, and that's where I really got my start in research. And then way before that, I finished my undergrad at UC Berkeley, where I studied electrical engineering and computer science in their EECS program. Yeah.
Awesome. Okay, so let's just go ahead and get started with the genesis. So maybe first tell us a little bit about your experience as an EEC student at Berkeley, maybe at a high level, kind of like what first got you interested in research. Tell us a little bit about kind of what motivated you to go to Princeton, and then also kind of critically how you got interested in this specific area of research.
Yeah, definitely. I attended Berkeley from 2016 to 2020. So this is a couple of years ago at this point. But it was a good experience. Berkeley was a really big school, so there was a lot of really smart people around, and it was really humbling to be there, I would say, in the first 2 years, because I had come from high school and I thought, oh, I'm this really excellent, probably top CS student. And then you meet all these like really fantastic, brilliant kids, and, you get a little bit humbled, but, after the arc of humbling, I think there's actually sort of this inflection point where I felt like, all right, I might not be the most brilliant EEC student here, and I was not by any means. But that, I got to focus and trust a lot more in sort of what I'm doing as opposed to sort of this idea that I'm, just smart. Um, so when I got to Berkeley, very early on, started to get engaged with kind of researchers. I didn't actually publish or put out any research as an undergraduate, but I was part of Berkeley's, at that point it was called Rise Lab, which is nowadays Sky Lab, and a lot of great companies like Databricks came out of that company when it's still called Amp Lab, and Anyscale was sort of the product of Rise Lab. And so there's a lot of great people there, professors like Jan Stoika. And I specifically got to work with Professor David Culler and Randy Katz's PhD students. There was a really great group. I had a mentor called Professor Jack Kolb. He was a PhD student at Berkeley, but now he's a teaching professor at University of Minnesota. And he was really formative in my early experiences. I think early on, I was very used to just like learning in the classroom, but at Berkeley, what I came to really value was having mentors and just being able to see people do what they do. Jack was incredibly formative in that regard. And I also had a great mentor called Albert Goto, who was at Berkeley. But yeah, at some point, Berkeley's so close to the Bay Area. So the plan was always to be software engineering, join like a great startup and just start working out of undergrad. But at some point I became sort of like pretty enamored with like, wow, this kind of research process looks interesting and maybe I should try to find out more.
Mhm. Awesome. Very, very exciting. So I'm kind of drilling down into your time at Princeton. So you worked on a lot of really exciting stuff. And eventually you kind of made this decision to go to Stanford. And maybe tell us a little bit about kind of that decision to get a PhD. You were sort of doing this thesis-based master's at Princeton. Princeton has an incredible master's program for people who don't know. I think it's generally fully funded. And obviously it's a great school. And Karthik, we're huge fans of Karthik. He's a great guy. And so like, kind of you, I'm sure you face this decision of like, do I want to go to industry? Do I want to get a PhD? Like, is this what I really want to do? In particular, because a lot of your work with things like SWE-Agent is like pretty practical work, right? Like this is a lot of stuff that, is being done in industry. As an example, Karthik was head of research at a startup called Sierra for a year during a sabbatical, and I was back at Princeton. So there definitely are applications of this type of work in industry. How would you sort of think through that decision of PhD versus doing some sort of applied research?
Yeah, yeah, you have definitely done your research. For anybody watching, this is fantastic pod. I feel, great job with the information gathering. All of that is correct. To answer the question specifically, I I kind of there was a pretty interesting point for me at Princeton where basically, like you said, it is a 2-year program. It's thesis oriented. The first 2 years, the first year I was doing like programming languages research because that's actually closer to what I was doing at Berkeley. And then I just so happened to be around the NLP group at Princeton, which led by Karthik and Donchi Chen, who's also a fantastic professor. And it was only in the second year that I had really gotten involved with the group. I have a great friend who just graduated from PhD at Princeton called Carlos Jimenez. He's my co-author for like half of my papers. But he's really the one I would say who was like incredibly encouraging. Again, kind of repeating the importance of a mentor. Carlos was just really kind to me and encouraged me to, engage with the NLP group. And like NLP is really the thing taking off, and language models are cool. And this was in like 2022, and I didn't really know any of this stuff. So what happened was, by the time I had graduated from the master's program, I had applied for a PhD during the second year of my master's while also looking for full-time jobs. And what happened was that was actually a fairly messy year, I would say, in that I didn't really do either one very well. So PhD program wise, I pretty much got rejected everywhere. And then job wise, I mean, there were offers, but after spending time with NLP and kind of engaging and meeting a lot of people who are very driven, not so much by career, but more by sort of research interest and vision. I reached this kind of fork in the road where I decided, okay, do I either just kind of take one of the industry jobs where it's great pay, it would have been great work, but it's not necessarily sort of something I really have conviction about? Or do I stay at Princeton, which at the time was kind of a tough decision because I would be staying as a research assistant. And, the reality is, you don't get paid super well. Like, you don't stay for the pay, you stay for the opportunity to kind of keep pushing research. So, coming from Berkeley and kind of growing up in the Bay Area and being sort of very like Silicon Valley pilled, like I would have said, like up until a year before that point, my default instinct would have been accept the job and kind of start, climbing the software engineering ladder. But I think, after a couple months of just being exposed to, wow, people are really coming up with original ideas. Yeah, the research at the end of the day, Cursor, all these companies, they've taken SWE-Bench and SWE-Agent and made it incredibly practical. But I would say those like early seeds of creativity, academia is not the only place for it, but I would say, I've been very fortunate to be in settings where I think the academic environment is actually extremely encouraging for being very creative and kind of like seeding these ideas and these tools in their V0 stage with language models. So anyway, TLDR, when I reached that fork and kind of had that exposure to what research could look like, I decided to stay one more year as a research assistant, primarily to like keep doing good work with good people, like with Carlos and with another really great mentor called Xunyu Yao, who did some really fundamental agent work like React and Tree of Thoughts. And that ended up being the year that I did SWE-Bench and SWE-Agent. And I think that was just like a huge inflection point for myself personally.
Mhm. Awesome. All right, without further ado, let's get into the world of very exciting research. And let's start off with Intercode. So maybe tell us a little bit about Intercode. Tell us a little bit about kind of what it is and the motivation.
Sounds good. Yeah. So right before Intercode, Xunyu Yao had put out the React paper, like synergizing reasoning and action. And this was like this was an era of NLP research that was very oriented around kind of doing chain of thought prompting. And there was a lot of exploration around prompting techniques, plan and, stuff like this. And Shunyu did the paper where it was like, hey, this is how you could hook up a language model to an environment. And this reasoning plus action paradigm seems to be very effective when you make language models do, multi-turn environment interactions. He had a very strong background in RL as same as his advisor Karthik. So I think they were able to kind of form a lot of those connections, which was fascinating. I had also worked on a project called Web Shop with Shunyu, where it was a very, very early benchmark for doing web agents. And so I had gotten a little bit of like practical training with Shunyu. And basically Intercode was very much like Shunyu's idea, where he was just saying like, oh, wouldn't it be fascinating if you took the React paradigm, and we already have experience doing this with web agents, but why not do this with code? And so the instinct at the time was you had human eval, you had NL to bash, you had multiple E, you had all these kind of like code completion benchmarks, but the format of the problem was very much like, here's the method header and here's a doc string, and then fill out the method. And so it was very input output oriented. Like you gave the language model the problem and you asked it to produce the function. There's no execution. There's no, here's a Docker environment, like the things that we're very sort of accustomed to today in terms of like, oh, coding agents and IDEs and tab complete. Like there was no notion of that when it came to code evaluation research about 2 years ago. And so Intercode was like a very sort of like building block work, which is why don't we take all of these, seek to seek code evaluations, slap a Docker environment, in them, and then basically make it such that the language model is not just trying to zero shot or few shot demonstration complete the task, but you actually give it like a bash environment or, a terminal environment, and you say, here's the problem. You don't have to solve it immediately. Like you can use this REPL environment, this Python environment, whatever, to try to do some attempts at the problem, figure it out for yourself what you want to do, and then come up with the answer. And so we did Python, Bash, and SQL. Those were the main three languages at the time, like Python, command line stuff, like, Python environment stuff, and terminal, and then SQL database manipulation. And yeah, I think it was a pretty well-received paper. Out of the gate, I think people thought it was a pretty clever idea, but it was fairly toy at the time. But I think it was a foundation for kind of a lot of the subsequent work. Yeah.
Awesome. And so sort of moving forward, after Intercode, we worked on, sort of worked on SWE-Bench, which obviously, maybe one of your most famous papers, but also just an incredibly impactful project generally. I think a lot of the audience probably is familiar with SWE-Bench, so with this one, we're going to get a little bit deeper into kind of what it is. Like maybe let's start with, at a high level, like what about SWE-Bench, kind of motivated you to work on this? So like, what were the early days of working on this, and then kind of what were some of the challenges that you faced while working on it?
Yeah, I really like telling this story. We pushed Intercode. This was around early summer of 2023, like, the NERPS deadline for 2023. And in June, I was kind of sitting there. This was right after my master's graduation, and I just, decided, all right, I'm going to stay another year here as a research assistant. And so I was just brainstorming with Karthik, and Shunyu was around at the time, and I was just thinking about basically the primary weakness of Intercode and a lot of code evaluations at that point, being that, things were kind of toy and not realistic. Like it was very sort of like, people are just evaluating on leak code easy, leak code medium, which was a really great evaluation for a while, but we were already reaching the point where human eval was like 80-90%. It was kind of getting a little close to being saturated. And so what you had seen at that point in time was a lot of people were creating human eval style code evaluations, but for different languages or for different domains. And so the fundamental task formulation remained the same, but you were just kind of toggling the source of the problems. And I think something about that was a little bit unsatisfying to me of like, you just keep doing this, like you're never really going to get to something where it's like, mind blowing in terms of like both the evaluation, but also the systems that you can build on top of it. So the sort of higher level premise was like, all right, I know I want to do a code evaluation to kind of showcase why something like Intercode is interesting. Because the main feedback we got from the reviewers was like, this is cool, but you don't really need an execution environment for this. And so the driver at that point was like, what's a coding evaluation? What is a task formulation that will really, really demand a model have to interact with an environment and do multi-turn agentic interaction? And so, like, the paper that followed that, which is SWE-Agent, was actually what that was. But, the benchmark was kind of the foundation piece that was really missing. And so I had proposed an idea to Karthik where, I had worked a while, I was very kind of into hackathons as an undergrad, and just kind of playing around with like open source repositories. And so this kind of issue PR workflow that I'm sure, viewers are probably quite familiar with,
Mm-hmm.
became very apparent to me of like, oh, like maybe if you just like crawl a lot of these pairs and you just look for the PRs that have an issue and then also contribute tests, that maybe you could kind of synthesize this into, a set of task instances. And what's fantastic is like you're not making any of this up. It's not like you're paying humans to sit down and just come up with random stuff. Like
Mm-hmm.
it's very organic. It comes from GitHub, and in theory there is sort of like a constant source of these new issue PRs being created.
Mm-hmm.
So proposed to Shinu, proposed to Karthik. They liked the idea. I wrote it down. I had started playing with it, and then I went to Carlos, who was there at the time, and I kind of like we were sharing ideas, and I chatted with him about it. He said, "Oh, that's a cool idea. Like, if you started working on it," and I said, "No, I'm just starting." So that was a fun summer. I would say it was me, Carlos, and then Alex Vedek, who's the third author for SWE-Bench and SWE-Agent, and we just spent the summer and we just hacked for like 2 months, and that was probably some of the most fun I've had as a researcher.
Mm-hmm. Awesome. Okay, so just in the interest of time, we'll kind of do a lightning round here. So,
Yeah, sounds
kind of
good.
like as brief yet thorough as you can, which I know is a bit of a challenging task, but I get to sort of do your best. Number
Yes.
one, benchmark construction. So in the paper, there's sort of three main stages. One is sort of repo selection and data scraping. One is attribute-based filtering, and then the last one is execution-based filtering. So maybe just tell us a little bit about how you came up with kind of that particular approach to benchmark construction.
Yeah, it makes sense. I mean, I think it was very practically motivated. So the first step is just like, okay, issue pairs exist. How do we actually crawl them effectively? And that was kind of step one. Step two, which was the filtering, was very early on. We had just crawled a bunch of PRs, and the decision at the time was like, all right, there's some PRs, they don't really have issues in tests. Do we actually want to focus on this? Do we want to like synthesize tests or synthesize issues? And people have done that after SWEBench, but at the time, we wanted like realism was a very, very dominant theme in the SWEBench development process. So the attribute filtering is when we kind of introduce these heuristics and criteria of like, we're not going to use PRs that don't have issues, that don't have tests, and those ended up being the main things. The last one was like, I mean, the whole premise of SWEBench is that you need to execute and that you need to interact with the code base. Like, it's very difficult to solve these problems just based off the surface form of the code. And that also ended up being like the hardest part by far of SWEBench, which was given a PR from Django from like 2023, how do you set up an execution environment for it that allows you to interact with that version of the code base without things breaking? Initially, we had used Conda. That was good enough for like V0 of the paper. But then after Cognition and Devin had launched, and that was really kind of a big moment for SWEBench because that's when everybody started evaluating on it, that we ended up having to port over to Docker. So yeah, that's kind of a quick rundown.
Awesome. I think like one of the key results that you guys sort of know in the paper is your best performing model, which was Claude 2 at the time, was able to solve a mere 1.96% of the issues. So, 1.96%. is not a very high number, right? Unless I'm just misunderstanding, what 1.96% means. Like that is quite low. And I'm sure that you guys probably theorized a lot of reasons as to like why this happens. And I mean, there's a lot of unique insights that just because of the interest of time we won't be able to go over. But at a high level, you guys talked about how difficulty differs across repositories. It correlates with context length. It doesn't correlate with issue resolution date. How fine-tuned models are sensitive to context distribution shifts, things like this. I guess at a high level, if you had to like name three reasons why you think like all the models were not great, or maybe like why it was only under 2%, what would you sort of say?
Yeah, for sure. Quick rundown. One, I think biggest reason, those models were just kind of fine tuned. I mean, like I don't think RLHF had really come out at that
Mm-hmm.
point. And so they're fine tuned to be chatbots. And so anything, particularly like interactions with the code base or any sort of like, here's some terminal feedback, was just incredibly out of distribution for models at that time. Not so much anymore, but that was probably reason number one. Number two, the context windows were tiny. Like we were dealing with like 4K, 8K. So you had in the very, very first version of SWEBench, like we didn't do agent stuff. We just did RAG and a retrieval augmented generation, and you would feed in like the problem statement and the code files it was supposed to edit. And for like, I would say a third of SWEBench, like it just didn't fit in 4K tokens. And you had to do weird truncation. And at that point, you're just like, the models just doesn't have the information to solve the problem. Last reason I would say is honestly just like how it goes about solving the problem. So it's kind of faded away very quickly after the, SWE-agent came out. But I would just say like, with every evolution, like if we're to keep doing code evaluations in the future, very excited about changing the paradigm as opposed to kind of just doing human eval or SWEBench extensions, because changing the paradigm is what exposes like very obvious issues. So I would say with SWEBench, like you just saw it solve problems human eval way, and there's a big mismatch there that the paper elaborates on.
Awesome. So sort of moving forward, two of the other papers that you worked on were SWE-agent and SWE-smith. And
Yeah,
then we'll spend a bit more time on Code Clash because that just came out and super exciting. So if you
thanks.
sort of had to give a speed run on kind of the key, let's call it impact of your work in SWE-agent and SWE-smith, what would you sort of say?
Yeah, for sure. Yeah, to keep it kind of pithy, SWE-agent, the idea was very straightforward, just like let's do React for SWE-bench. The idea is simple. The implementation ended up being quite complicated. Like we had had to figure out a lot of like, how do you communicate with Docker containers? How do you do A, B, C, D, E, F, G? But I think really impact-wise, Devin had come out with Cognition had come out with Devin in March of 2024, and then we had released Reagent in April of 2024, and we were certainly very lucky because there was so much excitement around Cognition getting like 14%, 13% on SWEBench at the time, and we had released a month later and we had gotten like 12%. We were only a little bit off from Cognition. So I would say the impact was just that like after that, you just saw like a tidal wave of people forking SWE-agent, exploring the scaffold. Basically, we had this idea of like, oh, you need to design middleware that facilitates language models being able to effectively interact with the code base. And that middleware is kind of curating the style of interaction. And it was very early on, just like, you should have tools, you should have guardrails that take into account like, the weaknesses of the model. You should have kind of context management or memory management. And I think all of those points have been extended into follow-up academic papers. I mean, I'd like to think you can see a lot of remnants of these ideas in Claude Code and Gemini CLI. They're very choosy about which tools, like each company kind of, now there's like Sweet grep and there's kind of these like focuses on search tools. That was just one of the contributions of SWE-agent at the time. So I think just sort of like what coding agent scaffolds look like right now, I think a lot of those like fundamental ideas you could probably trace back to SWE-agent. And then running into SWE-smith really quickly, there was a big sort of moment for us where when we were maintaining the SWE-bench leaderboard, around September of last year, like probably a little bit more than a year ago, there's a big change where up until that point in the leaderboard, the model was fixed, but the scaffolds were better. So you had people kind of submitting scaffolds with new tools, and the performance would go up. When Claude 3.5 came out, that was the first time where the scaffold was actually quite simple and it was held constant with Claude 3, but it was the model that was better. And so that immediately kind of invoked this idea that like your model can be better at agentic coding, with the intervention probably being data. And so the challenge is like, how do you actually scale environments, scale code bases, and scale task instances? How do you scale SWE-Bench effectively? And as we kind of mentioned, there's a lot of challenges with just doing SWE-Bench straight up. It's like pretty tedious and the failure rate is high. And then, if you go the route of just like no execution environments, like I think that bet has very much petered out because people have accepted that you do need execution to build effective coding agents. And so SWE-Smith was oriented around this idea of like, oh, you can actually take a code base with functioning tests, break those tests by introducing bugs, and those bugs are actually very effective task instances, and that methodology for collecting task instances just scales way more effectively than SWE-Bench does. So
Mhm.
yeah.
Awesome. And now we finally get to the final boss that we've all been waiting for, Code Clash. All right,
Yeah.
so I guess like first we can give like a kind of brief overview for people who are not familiar with this. So obviously, as the audience can kind of smell, like John has worked on a lot of really exciting stuff, and so one of his most exciting things that he's worked on recently is this sort of concept of code duels for sort of language models, where basically a lot of current evals sort of test language models on these tasks like fix this bug or write a test. But like here, you're sort of like, like we sort of code to achieve, goals like maximizing revenue or cutting costs or winning users. And so, with Code Clash, the idea is these language models are now competing across multi-round tournaments to achieve these goals. And so I think, one key insight here is this goal-oriented thinking, but I'm sure there's a lot more key insights and there's a lot more to sort of uncover here. So John, I guess maybe just tell us a little bit about kind of how, Code Clash works. I think at a high level, it's like you have these two language models, they enter a tournament. Tell us a little bit about kind of the mechanics of the rounds and how you guys kind of came up with this, like the specific implementation you guys ended up using.
Yeah, for sure. Basically, models play tournaments. So a tournament can have two or more players. And what happens in a multi-round tournament is that each round, there's two phases. There's the edit phase, where basically each language model maintains its own code base. So it's literally just language model plus SWE-agent manipulating its code base. And it can decide to do like it can do whatever it wants. And then after the edit phase, so all the language models get an opportunity to update their code base. In the competition phase, the code bases are then competing against each other. So what that means is like in practice with Code Clash, programming games end up being sort of like a really good set of arenas that we evaluate on. So if you haven't played a programming game, it's literally a game where you don't play the game directly. You write a bot that then plays the game for you. So it's not like Pokemon where you're playing hands-on. Sorry about that. But you're like writing a battle snake bot or something like that. And so you make these bots compete. And what's exciting is that after you run round one, each language model gets the logs from that competition phase in the previous round. And so in round two, when the language model begins the edit phase, it gets all of the logs from the previous round and it can decide what to do. And there's a really rich set of things that get introduced because not only are you trying to understand performance in the previous round, but you might be trying to understand what the opponent is doing. And so it's not just a matter of like, oh, I'm just trying to make absolute improvements to my code base. I'm also trying to sort of account for like what other people are doing. So generally, I'm very excited about this because one of the biggest issues and gripes that people have with SWEBench is that unit tests are too specific and issues are underspecified. And if you really take a step back, this whole paradigm of code evaluation has just been too ultra focused on tasks. Like it's just kind of small incremental steps. When in reality, as developers, like we don't care about tasks. We care about goals. We care about like what we achieve. And so that's what we're really trying to capture as an evaluation with Code Clash. Yeah.
Awesome. And so you guys sort of ran 1,680 tournaments, and I think that's around like a little bit over 25,000 rounds to evaluate a bunch of different frontier models. And you guys sort
Yes.
of identified that like Claude Sonnet 4.5 tops the leaderboard, but like no model wins across all of the arenas. And I think like you had a bunch of really excitingly named arenas, Battle Snake, Core War, Halite, Poker, Robocode, Robot Rumble. I am first curious how you guys decided to name these arenas, but also just kind of like why you sort of think, or is maybe like what are your intuition on the results? Like what are some patterns that kind of stood out to you?
Yeah, for sure. Yeah, I think with the arenas, like our biggest thanks go out to the open source communities because these arenas were not ones that we like made up or kind of like, just like came up with. These are like real programming games that have been around for a very long time and have a whole community around them. So, for example, one of them, Halite, was co-created by the CEO of Cursor, Michael Trull, and Benjamin Spector, who's a
Mm,
PhD student at Stanford. And they did this while they were at Two Sigma. And it was very much like AI programming game that Two Sigma had used for hiring back in like 2016, 2017, 2018. And there's a whole series of Halite. There's Halite 1, Halite 2, Halite 3. And these games were built, to help people learn coding, but also like it was just such like a crash course of just like, okay, the basics. But now, like, for Battle Snake, it's the snake game, so you're exploring like flood fill and how to like control the board. With how like it's kind of swarm collection and you're figuring how to gather resources and how to coordinate like large pools of bots. And so, like, we had saw, like, honestly, the community had just done such rich work already in the space, and we were just kind of stewards in terms of importing things in. So that's kind of the story behind the arenas. And looking forward, vision is that there's actually a lot more programming games out there, and we want to incorporate those arenas. So, like you said, we have 6 right now. But beyond programming games, I'm also really excited by this idea. There's a lot of simulations out there that mimic real world business processes. So I've seen things like supply chain management simulators, city planning managers. You have like cloud storage management, cybersecurity, financial markets, and a lot of this back testing software. And these are all arenas at the end of the day. Like you have simulations that help you test whether some piece of code or a code base or a business decision logic is optimized towards doing well at succeeding at some higher level business objective, doing well in the sense that it's competing with and beating other bots or other candidate logic or business logic solution. So we're just excited about adding arenas that are also going to reflect that real world use case. Because I think at the end of the day, language model automation is not necessarily language models do everything, but that language models write code that does everything. And then, sorry, just to kind of like add the most notable result, I think there's a lot of room for improvement on Code Clash. We took Claude 4.5 Sonnet on one of the arenas and we ran it against a top human solution. And if you look at the results, we ran Claude 4.5 Sonnet against an unchanging good human solution. It wasn't even the top one in that arena, just like a pretty good one. We ran it for 10 tournaments, 15 rounds per tournament. And then for the competition phase, because we're kind of running a lot of simulations we ran like 1,000 simulations of the competition per round. So if you multiply those numbers together, 10 times 15 times 1,000 or something like that, you get like basically like, I think the number is like 37,000. We have a blog post about it, but Claude 4.5 Sonnet's bot, which it gets to improve over time, loses like 37,500 simulations to 0. Like it doesn't win a single simulation against the human bot. And so I think it just speaks to like, we're probably a little over indexed on SWEBench now. I think the same thing that happened to human eval is happening to SWEBench now. And if we really want to build long running, powerful coding agents that can make meaningful decisions towards doing like state of the art or even superhuman things using code, then we should be focusing on goals and not tasks. Yeah.
Mhm. 100%. So in the future work section, you guys talk a little bit about kind of how right now you guys haven't yet explored VLMs, and sort of supporting multimodal feedback is on the roadmap.
Yeah.
I'm sure there's a ton of sort of future continuations on this work and generally on the work that we've sort of discussed in the podcast. What are some things that you're really excited about, kind of opening up more broadly to the this world of SWE-agent and SWE-bench and now Code Clash? Like, what's up next?
Yeah, definitely. Yeah, I think the future is bright. There's clearly a lot of interest around coding agents these days. I think the most exciting thing to me is making coding agents more and more economically useful for non-coding related tasks. So up until this point with like SWEBench and human eval, you're doing code to make better software for the sake of making better software, which is I think, a very fundamental step towards making better coding agents. But I think that story, like if that's it, it's kind of unsatisfying in a way. Because at the end of the day, we don't just resolve GitHub issues for the sake of resolving GitHub issues. Like code is very much just a vehicle to, you know, make things more convenient and improve accessibility and give people more access to things. So I think just like pushing coding agents in a direction where we think about more about like how people want to use it, why people want to use it, kind of the human AI collaboration side. We make things more apparently economically valuable. We allow like more stakeholders to participate in sort of how coding agents operate. And there's a lot of different interventions beyond just like IDEs. Like I think right now the coding agents are really exciting, but it's really like coding tools for coders. And I think what gives me a lot of conviction and
Mm.
motivation is like at the end of the day it's like coding for all, and what does that look like beyond just like a software engineering opening Copilot. Like I think it's cool, it's a good step, but I think there's a bigger story to tell than that.
Hmm. Awesome. And I guess like more broadly, I mean, there's a lot of different startups that have sort of been doing sort of code generation things. Like for instance, there's like I think Open Hands might be the name of it, and then
Yeah.
obviously there's Cursor, and then there is there's a ton of things going on. Like what do you sort of like what are you sort of excited about in the code generation space from like an entrepreneurship perspective? Like what do you sort of think are some of the key maybe differentiators between the ones that are doing super well and sort of have really great like I guess like user bases and growth, and maybe ones that are not doing so well?
Yeah, for sure. I think after we did SWE-Agent, it was really fun to maintain the SWE-Bench leaderboard because, after Cognition, had launched and they had obviously had a very successful launch and a great Series A. You had for a period of time a lot of companies that were like, hey, let me post my SWE-Bench score and attach it to my announcement. And so that was really fun. Like Factory had done this, Matan Ginsburg, I think, they had launched, oh, we got the top score, and Factory announced their round with SWEBench, and to a lot of, great reception. And then you had things like Warp, and, they announced as well on SWEBench. And so that was very exciting. I think, like, if anything, it kind of speaks to how fast things are moving. I think like a year ago, doing kind of scaffolds and building kind of pretty intense systems around facilitating language models as software engineers for production code bases, the things that Cursor and Cognition and maybe Klein and Factory are really competing for. I think a year ago that probably would have made a lot of sense. A year later, I think this field is, that market is really, really dense at this point. And so personally for myself, like if I was, in the mindset of someone wanting to build a new thing, I think I would just focus like going beyond the paradigm of like, hey, we have this intense system for like resolving tickets. I mean, obviously it's like a wonderful, it's a really cool area to be in just because like resolving tickets and kind of building software for software engineers is not going to go away anytime soon. But I think personally for myself, and from what I understand, a lot of the frontier labs are not necessarily focused on let's optimize for the IDE. Because I think really the vision and the hope at the end of the day is if you want super intelligence or AGI or whatever you want to call it, You want a coding agent where like you don't have to like laboriously write up a task documentation, write an intense PRD, and kind of handhold and like, verify and check off every step. Like the insane thing would be like you give it kind of a meaningful objective, like a open-ended objective that is like readily verifiable automatically, kind of like in the code clash setting. You give it kind of like a lightweight prompt of like, hey, I want you to build like, back test against this market. I want you to come up with the best strategy possible, and you have like a market simulator, or like, hey, city planning, like here are the constraints, come up with the best layout that optimizes for these three, four things. Like you have like a prompt that's like, 50 sentences at most, along with like the appropriate environment. You just run the code agent and you come back after 12 hours and you get literally something that's state of the art. Like it produces software that is state of the art or better than what any human could come up with. So to me, I think that's the coolest thing. I think we're like progressing towards that. I'm sure all these kind of like scaffold companies and IDE companies these days, I'm sure that's probably something they have in mind. But yeah, I would just be excited to move towards that. Yeah.
Awesome. And without further ado, we are so, so, so lucky to have you. Thank you so much for coming on the podcast.
Yeah, I appreciate it. Thank you so much. This is a really fantastic set of questions. So yeah, I really enjoyed it.